considerably higher than what the AIS can offer, for instance. And it has a pretty high reliability. In Norway, this has now been completed, the coverage of this. So this is a system available in the Norwegian waters now, which we really think will solve some of the problems. If you stream this together, you can achieve up to maximum maybe 200 kilobits of bandwidth. There's also different module schemes, which means that you can increase this even more. But then, of course, that has some side effects, and the range is probably a big side effect of that. Then you also have WiMAX, which is a long-range adaptation of the Wi-Fi mode, in a sense. We've seen several cases where this is in use, especially in harbor areas. There's pictures from the coverage in Singapore, on the bottom right there. There's also a picture from coastal areas in Norway, where it's used for what's called the last mile. That is, giving really broadband to customers, which is daily commuters sitting on passenger ferries in the Norwegian fjords. So it's definitely something which can be used. The conclusions of this paper is basically that new e-navigation services will emerge. They will require more bandwidth. And the satellite system, they cannot provide coverage in all the areas. They may not have sufficient reliability for a given task. And of course, AIS, we have to develop and continue with that, but they cannot carry particularly high loads. And even if we got the third frequency that we are fighting for, we would rather use that for space applications instead of increasing this. But I think maybe the line that is missing here is that this should really be like a wake-up call, because I think that IALA has to fight both for frequencies and to actually implement reliable and secure communication systems. Because I believe the e-navigation that we are moving into, the foundation of that is good communication. And I don't think we have that foundation in place today. I think we take too much for granted on this. And this paper shows some of the deficiencies of some of this. And it was very interesting to listen to Professor Shufang Sang just before me, because I think that network approach is really needed in the future communication in India. Thank you very much for listening to me.
Thank you, Arve. The next speaker is Michael Card. He is advisor of the Zegenleitboy company in Japan, a member of the AIS Technical Working Group of the e-Navigation Committee. Michael.
Thank you, Chairman. Ladies and gentlemen, I'm going to talk about AIS 8ON, and I'm going to cover some history of the development of the hardware, the physical realization of AIS 8ON today, current uses, potential for the future, and then just a few conclusions. Many people have been involved in the development of the hardware, and many organizations, and I'm pleased to see a number of the people who were in the early days are attending this conference this week. My involvement started around about the year 2000, and work had been done before that in various parts of the world, but the products that were developed at that time were not compatible with what was then called UAIS, or Universal AIS. So perhaps the first product was the Akari 400 product, which was shown at the Sydney conference 8 years ago, and was the first AIS 8ON. It used a ship's Class A unit, which was controlled by an external microprocessor unit, and in effect converted it into an AIS 8ON. It transmitted the three messages that you're familiar with. Message 21, the AIS 8ON report for navigation. Message 6, the addressed binary message, and message 8, the broadcast binary message. The typical AIS ATON product today, which is available from a number of different manufacturers, meets the new IEC test standard and has more functionality. Most people now are most interested to use FAT-DMA for access to the VTL in order to reduce power consumption, but there are still cases where we need RAT-DMA access, for example, outside the range of AIS base stations. The modern AIS ATON unit today can be found in various physical configurations, and I will not run through all the pros and cons of each of those, but you can see them in the exhibition out there on various stands, and people are approaching it in different ways, and the different means of packaging give different advantages to the potential user. The typical current users of the AIS ATON are these three. The three that we originally all thought about many years ago. Message 21, the obvious one for navigation. Message 6 is used extensively for monitoring the co-sighted light and power systems that are often in place at an ATON AIS site, and of course the meteorological message. There are other uses today, and some of them have been described here, but I suggest that these three uses are the ones that are very commonly used globally. It's my view that the potential or the future use of the AIS ATON will be used for these purposes here. We're still back with, of course, navigation and with environmental data, but people are becoming interested in transmitting AIS status, ATON status. That could be visual ATON, for example, status started to shipping, and possibly vessel surveillance. And you will know about the work of IALA on virtual AIS ATON, and I think that the physical AIS ATON will have an interesting role to play here. The benefits of using an AIS ATON to broadcast information for the benefit of shipping are pretty well known and have been covered earlier in previous conferences and by other speakers this week. For the future, it's my personal view that the advent of multiple GNSS systems, for example, we now have GPS, we have GLONASS, we have Compass on the way, and probably Galileo. When AIS ATON units of the future have multiple GNSS capability, we can expect that the accuracy of their position fixing and the reliability of that position fixing will increase quite dramatically. There's been quite a lot of talk also of using DGPS correction broadcasts via AIS message 17. I personally am not aware of this having been developed very much, but it's certainly a capability. And we've already seen from Stefan Bober's presentation this morning the special applications of AIS for inland waterways, and similar work is being done in the United States and in other countries. Not so long ago, the work of the IEC AIS working group made some changes to the way that message 21 data would be used, and what were then called the bits for regional use became the AIS ATON status bits, and that was inspired by some very interesting work from Denmark about how those bits could be used. So it's now possible to monitor ATON by encoding the ATON status data within message 21. It's limited data possibility, but it does allow a very nice and compact way for an administration